41. Got it? Yeah. So enter the word problems. Now, when you're given a word problem, you'll have to read and interpret the question in order to produce. Right? You'll have to read and interpret and then produce an inequality that goes with it. Inequality is essentially, it essentially provides a restrictions to possible answers. Okay, that's probably worth a different color. You're saying, hey, it's not everything, but hey, I'm going to restrict the plane a little bit and just have certain options for my solutions there. First off, type of data, right? So when it's discrete, you will round POIs. Maybe highlight the whole thing. Discrete data will round POIs. Discrete is things you can count. Only exist in whole quantities. This goes back to chapter 8 when we did the whole conversion, like how many cans of paints can you buy, right? Can you buy cans of paint? Did I say paints? Anyways. And so we had to round because you can't buy partial quantities, right? So examples would be coins, people, cans, etc. So whenever you see something like that, you need to round your POIs. So example, if you use your calculator and you come up with a POI that's 6.918, let's say, and the 6.91 represents, I don't know, number of people, number of cars, something that only exists in whole quantities, we will round. We will say 7.8. Okay, so this is your calculator. This is your answer. I want you to show me both. I actually prefer that, but we round. If it's continuous, I think of things you can measure. So example, it'd be area, volume, distance, temperature, you name it, right? All those things can be measured. That's continuous. Time, I guess I should go with time as well, etc. Don't round, okay? Don't round POIs. Don't round POIs. So you'll find actually that a lot of times you're going to round. Quite often we're going to talk about rounded scenarios. Next part, so I'm just getting you ready before we jump into the actual meat and potatoes, right? Almost all cases, right? Almost all cases involve data that cannot be negative. Therefore, your graph will be restricted. Okay, I'm going to use a different color. Graph will be restricted to quadrant 1. And therefore, one more time, we will state the implicit constraint. This is implied. Implicit, think of it's implied. We're just assuming that that's the case. And this throws students off quite often. So it's basically saying, you could do it separately, that x is greater than or equal to 0, and also that y is greater than or equal to 0. So we're assuming that x and y have to be greater than or equal to 0. That's what this little statement is saying. So you can either state it like this, the shortcut, or you can state it separately. It's up to you. This is probably, I think you might forget. So I'll just do one of those when you read through it. It's like, hey, this is the implicit constraint. We're implying that x and y are greater than or equal to 0. So this is the comparison right now. We've been doing no context so far. We considered all 4 quadrants, right? Quadrant 2, quadrant 3, and quadrant 4. We considered all 4 quadrants, not a problem. The only POI here would be this. Only one POI. We would consider this our solution region. And we can guess, right? This is what, 12.9? I think I made it land right on the intersection there, so that's 12.9. Okay. I'll do it one more time down here. 12.9 is the POI. Nothing else is a point of intersection because your solution region is just surrounded by one point of intersection. But if there's a context, let's try this one more time. Grab a ruler if you have one. Let's just replicate this. This is going here. What is that? Right halfway between 20 and 30. So we're going to make a point right there. And it crosses at 20, 0. So we're going to put a point right there. So that's a solid line. So when there's a context, it's just quadrant 1. Quadrant 1, everything stops. Like we don't go past because that's not allowed. Also, we don't go past here because that's not allowed. We stick with quadrant 1. What about this one? This one here is just one box over right there. Just one box over the 10. And it goes through 40, 0 here along the x-axis. So we will go dashed line here. And this is zoomed in, right? Just to quadrant 1. This is going to be our solution region right here, this little sliver here. So we're going to write solution in here. And we're going to shade everything outside of that. But we're going to stick to quadrant 1. We're using reverse shading, of course, because we're shading the false regions. And this line coming down on the solid line here, we're shading everything like that. Here, in this case, actually, the x-intercepts here are POIs. So we have 3 points of intersections. 1, 2, 3. 1 there, 1 there, and 1 there. So we would have 12.9 still stays. That's this one. This one right here is 20, 0. We might have to use our calculators for these later on, but and this one here is 40, 0. So now these two here are newer. Okay? So I'm going to actually use a highlighter for these. So I'm smudging everything up there. But those are new. Okay, these here new because it's a word problem. So that's how things are going to change now. We used to treat it like this, no context around it. Now we're going to have a context around it. You know what? We can say that, right, this could be cars and this could be buses. So maybe a rental company is renting out cars and buses. So now we have context around it. So we can't go into the negatives. You can't have negative buses. You can't have negative cars. So we just stick with quadrant one. Okay, let's keep going. So we're transitioning over to this now, where x-intercepts or y-intercepts are, in fact, can be POIs. Okay, let's continue. Let's write some inequalities here. Before we start here, I made a little note for myself to tell students in the, I'm gonna say see keywords on page 48. We're gonna go to 48 to add some keywords that are gonna help you out. Let me see here, 48. So go to 48 to help you out. I would strongly recommend you having these on your study sheet, these keywords, because they tell you which way to point, okay? Keywords when writing inequalities. So I have two camps. The one camp is if you want the inequality symbol to look like this, and the other camp is the inequality symbol looks like this. So what you're looking for here is up to, at most, maximum of, capacity of, holds up to, no more than, like I can't give you an exhaustive list. Like these are all the ones you're ever going to need. But if you have these, you can often read the question, be like, yeah, this one is telling me something along the lines of at most, right? So you're going to have some words to go by. And then if you want this one, you're looking for at least minimum of, no less than, I don't know how to do this one, but it just came to me, this or more. Like you want, 3 or more puppies or something like that, right? Like if you think of that, this or more, if you indication that you want more than just that, then you're also thinking of that inequality, right? So these are the key words here to help you out. I would say study sheet, because unless you're comfortable with it, unless you know exactly when you read this, it's like, you know what, I don't need that on my study sheet, which I would still say do it, because you might draw a blank and then you're going to regret it. So make it nice and small, not too big, and try to fit that in. So maybe put a finger on this, keep this handy, because as we're doing the examples, you might want to revert back to this, okay? Because you're still learning. Okay, let's go back to 42. So I do have the keywords up here, but I think it's a little messier than the one I just did. Okay, so write inequality for the following statements. Let X be the number of uh, people and Y be the number of pets. So I'm going to mix people, and that's going to be my go-to here. I'm going to use yellow and pink. Okay, so let X be number of people. We're going to do that quite often. We're going to define our variables, and let Y be the number of pets. So there we have it. So given that, implicit constraint, let's write that down. Implicit constraint. Implicit restriction, it's the same thing. X as well as Y have to be greater than or equal to 0, especially if you're thinking people and pets, right? You can't have negative. It's not money or anything else, so we'll just go with that. So this is a given. It's just implied, but we're actually stating it. I might ask you to state it. Okay. A building can accommodate no more than 400 people. So first of all, we're thinking people here. 400 people. So that's number of people, right? That's my X variable. So you should be like, okay, we're definitely talking about the X variable here. And I want no more than 400 people. So you kind of have to, know we're relating people and the number 400. And you almost want to be able to read that statement and look at your inequality and say that's saying the same thing. So in this case, you want no more than 400. So the number of people has to be less than or equal to 400. That's what that statement is saying. If you go to 48, I don't even know if I have that as my keywords. I'm going to check. Oh yeah, it is right there. No more than. We have the inequality of less than or equal to, which is what I used there. So it's confirmed, right? It works. Next, a dog park can hold up to 45 dogs. When you see that, you're like, yeah, we're talking about the Y variable only here. Okay, this is exclusive to Y variable. So you're going to go Y and 45 in this case. And the dog park can hold up to 45 dogs. Can't have 46, 47, that's a no-no, but up to 45. So Y has to be less than or equal to 45. That's what you want to write there. Can hold up to 45 dogs. Next, a dog park can have up to 100 dogs and owners combined. Okay, now I don't know if you're realizing this, but I'm mixing up people, right, and dogs and pets. In other words, I have X variable and a Y variable there combined, talking to both. So when you're thinking combined, you're thinking, right? You're thinking plus, right? You're going to add them. So that's what we do. We go the number of owners and pets combined, something, something, 100. What symbol, what inequality should go in there? Or you're saying that the combination of these two, right, can be up to 100. So you have to say less than or equal to 100. So if it were to add up to exactly 100, we're still good. You can have less, but not more than 100. That's also what this statement is saying. Okay. A vet can see up to 24 pets a day. Pets, that is my Y variable. So the vet and 24. So when we're talking about the number of pets in particular, it has to be less than or equal to 24. So the vet can go all the way up to 24, like the number of pets can go all the way up to 24, but not surpass it. Next, a committee needs at least 5 members. This is our x variable only. We're talking only about people here. X, 5. Which way is this one going to go? At least 5, it says, right? Then focus on this. The number of people has to be at least 5. So that means that x has to be greater than or equal to, because of the word at least. At least gave me the hint that I had to face it the other way. And if you go to 48, it should be there and it should tell you. A stadium allows up to 20,000 visitors and pets combined. How would you do that one? Well, I don't know if you're a baseball fan. I'm not necessarily a baseball fan, but the Gold Eyes, they're going to have the Bring Your Pet to the Stadium event. I heard that on the radio, so maybe that inspired me on this. But visitors and pets, right? So your X and your Y combined. So here you have both variables at the same time. So both combined allows up to 20,000 visitors. So the 20,000 will definitely be in here. And so you have to kind of think of it this way. These two combined has to be less than or 20, because it's saying up to 20,000. So you can have anything 20,000 and below, but you cannot surpass the 20,000 mark. All right, next. Two numbers have a sum that is less than 20. Okay, two numbers. Twice the first number plus 5 times the second number is at least 50. And you're thinking, how do I do this? Well, when there's nothing, there's a completely different question. Let x be the first number and let y be the second number. And so we're told out of this statement right here, this statement right here gives us the first inequality, inequality 1. Let's write that one first. The sum of those two numbers is less than 20. So that's our first inequality. How do you know it's an inequality? Because less than, right? That gave us the hint for that. And this part right here is inequality number 2. So it says twice the first number, so twice the first number plus 5 times the second is at least 50. Right? At least, if you have this on your keyword list, at least is greater than or equal to, and you have 50 there. So I'm going to highlight at least and put that here. This system spans all 4 quadrants, okay? This one is one where you don't have to worry about an implicit constraint or anything like that, because it actually would go all 4 quadrants in this case. All right, where are we at time-wise? This is what I'm going to assign to you, okay? There are a bunch of questions where I ask you to just write in inequality. So that's going to be 44 and 45. And I will post the key. Here's this is how I know you've tried, right? If you fill in that whole page and you get every single one of them wrong, I can live with that, right? But if you just say, I didn't get it, and it's just all blank, I don't think you've tried. Okay, give it an honest try. Be comfortable writing, because graphing is easier when you know how to write your inequality. If you don't know how to write the inequality, you're gonna struggle with the rest, okay? So it's gonna hinge on this right now. So thank you very much.